Oh yeah! Welcome back, kiddies, to our second video lesson of Chapter 4. We're talking about solving proportions using the cross product, yeah. Sorry, kids. I got a little jacked up because right before this video, and you'll see it in a little bit, watched myself a little Macho Man and Hogan from the 90s. It's pretty exciting. I'm going to show you in a little bit, yeah. Okay, so let's get started. Today we're going to talk about solving proportions using what's called a cross product. This might be familiar for some of you. Again, a lot of you probably know this, like to do it when you see fractions, and I kind of avoided it last section, but we're going to come back to it now and talk about how do we solve proportions using a cross product. Remember that a proportion is simply two ratios that are equivalent. So for example, 1/2 we can say is equivalent to 4/8. So we kind of set this up last section, is that what if I said, okay, if I have the ratio of 1 to 2, 1/2, what would that be equivalent to if I'm talking about a whole of 100? Now, some of you may be able to think about this, okay? But the way I had you solve this is I had you solving this using ideas that we did in Chapter 3 on solving equations. Today we're going to use a special property called a cross product, okay? It's a special property only used to solve proportions. Now, a lot of you take this one example and we'll use it to any time you see fractions. Anytime you see a fraction, you think cross product, yes, no, oh yeah, no, you don't want to do that, yeah. Okay, but only cross products are only used to solve proportions. So here's what it says. If you look here, we have the example 3 to 4. This ratio, 3 to 4, is equivalent to 6 to 8. So they show it here in blue and red. What if you look at the 4 and the 6? If you multiply across, so 4 times the 6, what you get is 24. And the 3 to the 8, also 24. Now they write this as kind of stacked on top of each other as a fraction, so I don't really like to look at it this way, but instead I like to view it like this. Okay, and this is how we're going to do it. If you see a ratio, for example, 3 over 4 is equal to 6 over 8, cross product, what you're going to do is you're going to take the denominator of one and multiply it by the numerator of the other. So 4 times 6, and you're going to set that equal to the product of the other numerator times the other denominator. So 3 times 8. And here's what you should see with this property, that if you multiply across the numerator times the denominator, what you get is that 24 is equal to 24. So as an equation, that remains true, which again proves this idea that a proportion is simply two equal ratios, just written in different ways. Okay, so that's what we're going to do to solve proportions using a cross. All right, so here's some examples. I'm going to go through these a little quick. So again, we could go through and solve these like we did last section of actually solving these using our properties of equations, but instead we're going to use a cross product. So again, what we're going to do to a cross product, we're going to start with the numerator of one, and we're going to multiply it by the denominator of the other. So I'm going to have 3k times 3, and I'm going to set that equal to the product of the other numerator and denominator, 27 times 2. And what I'm going to do is solve each of these individually, or simplify them, sorry, and then we're going to try and solve for k. So this one I have 3k times 3. I'm just going to multiply to 3 times 3 to get 9k. And I'm going to set that equal to 27 times 2 is going to give you 54. Now what am I left with? Well, 9k equals 54. That's a one-step equation. I can divide by 9 and get k equals 6. So notice how it simplifies a lot of the work compared to what we did last section. Okay? Now, this is going to help us to when we get to more complicated problems like we see in number 2, and holy cats, we'll get there in number 3. But we're going to apply this same property. The cross product says I'm going to take the numerator of one and multiply by the denominator of the other. So in this one, I have 7 times x, which I write as 7x. Okay? The next one, I have 3 times, notice this says 2x plus 5. So I'm literally going to write down what that says. It's 3 times the entire 2x plus 5. It is not the 3 times the 2x. Now I'll show you a shortcut way, but what you're really doing is you're multiplying the value of 3 in the denominator by the entire numerator 2x plus 5. Okay, so now you look at this problem, what do I have to do? Okay, well I'm going to keep my 7x on this side, that's fine, but on this side I'm going to have to distribute my 3 to the 2x and the 5. So 3 times 2x is going to give me 6x, 3 times 5 is going to give me 15.
What's left over now is an equation where I have variables on both sides. So we have to think about last chapter, how do we solve an equation with a variable on each side? We must get the variables to one side. So I see that if I bring the 6 across, that's going to leave it positive. So I'm going to subtract 6x from here, bring 6x across, 7x minus 6x, 7 minus 6 is 1x equals 15. Therefore, that just means, again, 1x is just x equals 15. Okay, so again, simplifies a lot of the work and makes this a problem that looks rather difficult a lot easier to solve. Now, the shortcut way that I was talking about, what you can do, the biggest mistake kids are going to make here is to take this 3 and just multiply it by the 2x and say 6x plus 5. But if you think about this, you're multiplying 3 by everything on top. So what you could have done right away is taken the 3 and distribute it to each term right away. And I'm going to show you how to do that in this problem here. Okay, so I'm going to take, again, 6 and multiply it to w minus 10. So I'm going to take the 6 and multiply it by the w, 6w. I'm also going to take the 6 and multiply it by the minus 10. So 6 times negative 10 is going to be minus 60. So it's just a shortcut way. It just saves me a little bit of work. I'm going to do the same thing with the 2. Now notice the 2 is up here. It's the same idea. Instead of saying 4 plus 2w times 2, I can say 2 times this, which means I'm going to take my 2 and multiply it by 2w, which is going to give me 4w, and take my 2 and multiply it by 4, which is going to give me 8. Okay, so now what I basically did is the same thing I would here, it's just I skipped an extra step. If that confuses you, write it out. Okay? Now, again, I got variables on both sides of the equation, so I'm going to have to get them to one side. I see here I'm going to subtract 4w to get that to cancel. Bring it over here is going to give me 2w minus 60 equals 8. Last thing I'm going to do is add 60 to this side. It's going to cancel. Going to leave me 2w equals 68. And the last thing is divide by 2 on both sides, and I'm going to get w equals 34. Okay, so this one I just did a shortcut way, but again, notice how the cross product makes this problem a lot easier to solve. All right, I have 2 examples here. I want you to try these 2. So what are you going to do right now? That is right. You are going to P-A-U-S-E, pause the video. So pause it and give these a shot. Ready, set, go. All right, here we go. Here are the solutions. So the first one, again, doing the cross product. I took 4 times 3d plus 6 and 7 times d plus 1. I had to distribute on both sides, so I distributed a 4 to each term to get 12d plus 24. And then I distributed the 7 to the d plus 1 to get 7d plus 7. I then looked and saw, okay, 12d, 7d, I'm going to bring the 7d across to give 12 minus 7 is 5, plus 24 equals 7. Then I subtracted 24. 7 minus 24 is negative 17. So what I'm left with is 5d equals negative 17. Don't freak out. Divide by 5. 5 does not go into 17 or negative 17, so just leave it as a fraction. You get negative 17 over 5. That's okay. You can get a fraction. Next one I have, this one I did a shortcut. I'm going to multiply negative 2 times this entire term. So what I did is distributed right away. So negative 2 times 11 is negative 22. Negative 2 times negative 4c is positive 8c. Then I did 11 times c, which is 11c. 11 times negative 8, which is negative 88. I brought then the negative 8, I brought the 8c across by subtracting to give me 3c minus 88 equals negative 22. Then I added 88, divided by 3, got c equals 22. All right, so let's take a look at an application of proportions and using the cross product. It's something called a scale drawing. I can guarantee many of you have seen this at some point in your life. How many have looked at a map? How many have looked at a map on your phone, for example? Anything that we take from a large scale and draw it down to a small scale, you are using a proportion. A scale drawing or a scale model is simply a drawing that shows the dimensions of an object, but it takes an object from real life and puts a scale to it or sets a proportion or a ratio such that you can actually draw this thing what's called to scale. So notice on this diagram we have a scale of 1 inch to 12 feet. So that means when they draw this out, for every 1 inch that they put on this, it represents 12 feet. Okay, so you can take a look, for example, at this garage. This garage appears to be pretty square. If you were to measure this, this is pretty close to 1 inch. 1 inch. So you know it's about a 12 by 12 garage. Okay, you can look here. Your kitchen's about same length, about 12 feet, but now it's half the height. Okay, so you know that this is probably a 12 by 6 foot kitchen. So again, when I can look at this is I can say that depending on the length here, I can represent the length in this drawing to be the same ratio as what it would be in real life. This is a scale drawing. Again, we see this a lot with maps and things like that.
Now, another application of a scale model, is when you have action figures, and these are not dolls,
Okay, now I'm doing Macho Man's voice there, but what we got here is another example. Okay, we have ourselves the Hulkster, the real American hero, my friend. Say your prayers, eat your vitamins, be true to yourself, be true to your country, be a real American man, church. Okay, we have the real Hulkster, who is 6'7" or 79 inches. Okay, and he's got 24-inch pythons. Those are these suckers right here, those biceps. Okay, when they make an action figure, they try to make an action figure to be a scale replica. Now, back in the 80s in the old school action figures, you can see the little tiny legs and the huge arms, but nevertheless, this action figure, which I do have in my classroom, is 5 inches tall, and its pythons measured around is about a half an inch. Okay, so you can take these two things, and what you can do is you can figure out what is the ratio, right? A scale model will have some sort of ratio. So to find that ratio, well, I can look at a ratio of the height, for example. The real Hulkster has a height of 79 inches. My action figure has a height of 5 inches. Now the same can be said about the pythons. Okay, the real Hulkster has pythons of 24 inches. The action figure has the pythons of a half an inch. If this is a correct scale model, what we can say is that the ratio of the heights, which we see here, the ratio of the heights, are the same as the ratio of the pythons, if this is done accurately. Okay? So really, mini action figure Hulk Hogan has the same proportion, same ratio of biceps to height that the real Hulkster would have. So you see this a lot. Action figures, maps, all those things. Okay, so I'm going to go through a couple examples here of applications and how we can use these cross products to solve proportions. So here I have a map example. We have a map of Ohio. Why Ohio? I don't know. Ohio sucks. Who cares about Ohio, right? Just kidding for those of you that live in Ohio. But for those of you that have a metric ruler laying around, which I'm guessing you don't, but being that I'm a math teacher, of course I have one laying around. I got one right here, though you can't see it. What I'm going to do is I'm going to measure the distance from Cleveland to Cincinnati, Ohio. So if I look here and I line this up, I know you guys can't see it, but here's what I get. I get the distance from Cleveland to Cincinnati on my map is 4.5 centimeters. Okay, so that's the distance from Cleveland to Cincinnati on this map. Now notice that this map gives me a little scale. It tells me that 1 centimeter on this map represents 85 kilometers in real life. So we can use this scale to actually set up a proportion. The scale tells me that 1 centimeter is equivalent to 85 kilometers. So I can use that ratio, that scale, to figure out on my measurement, if I measured 4.5 centimeters, how many kilometers would that be? And notice I labeled that as X. So here's what I did, is I used this scale model to set up a proportion. I said that the ratio of centimeters to kilometers should be the same as centimeters to kilometers over here. So when I say putting X down here, X is going to represent how many kilometers is Cleveland to Cincinnati in real life. Now how do I go about solving this? Now solving it is the easy part. We just learned about cross products. So I'm going to take, for example, 1 times X. So 1 times X is going to give me X. And that's going to equal 85 times 4.5. Plugging that into your handy dandy calculator, what you get is that X is going to equal 382.5 kilometers. And notice when we do that, we have solved for X using that scale model. Okay, so we get that the distance from Cincinnati to Cleveland is 382.5 kilometers. Okay, now kilometers, that's metric. Normally we talk about in miles, but one mile is about 1.6 kilometers. So you can take this and almost double it. So you get about probably a little less than, or a little more than 600 miles. Okay. Now I want you to see if you can do the same idea. We have a ship model kit sold by a hobby store. It has a scale of 1 feet to 600 feet. A completed mile of the Queen Elizabeth II. Fancy jargon there, but the Queen Elizabeth II is a boat. It's a little ship. Okay, there's my little diagram of a ship. And it says that the model is 1.6 feet long. So I want to know, what is the actual length of the Queen Elizabeth? All right, so I want you to give this a try. Here's what you're going to be using. Think about the last example we did. The scale that you are given here is that 1 foot is equivalent to 600 feet. So if you know that the Queen Elizabeth is 1.6 feet long, I want you right now to set it up and figure out how long is the Queen Elizabeth II in real life. So pause the video, give this a shot. Ready, set, go. So comparing what you got, hopefully the same. I got 960 feet as the length of the ship. That is about, you got to think, 300 feet is 1 football field, so that's almost. It's about 3.5, almost 4 football fields long. That's a pretty big ship. All right, to leave you guys, I got yourself a little bit of video as promised. Here we go. Here are the Hulkster and the Macho Man. Oh, yeah, let me tell you something, brother.
Gentlemen, we got a taste of it a little earlier on here on Saturday night's main event when the madness met the mania. I am talking about Macho Madness and Hulkamania, 2 mega powers beating here tonight. Hulk Hogan, what is happening?
Well, you know me, Gene, we really don't know what we're dealing with here, man. And I'm just kind of a little worried about locking up here. Because we just might blow the whole planet up, you know. Everybody knows that Hulkamania is the strongest force in this universe. But when I hit that ring and I saw what the madness was all about, I realized there was a whole nother universe out there, a whole nother frontier, and the power of the madness and the mania just blew my 24-inch guns out.
You mean to tell me there is another solar system, Macho Man?
Unbelievable. I'm still in a state of shock right now. In fact, I don't think the movie coming down for a long period of time. Yeah, reckless abandon is what it used to be. Yeah.
But Elizabeth opened up my eyes. He's a big man right here. The big man. Yeah. He endorsed Macho Man this and gave me direction. Yeah. Reckless abandon used to be the direction now with the mega, the mega power. Yeah. Mega power. Yeah. I feel the power now. I feel the power right there. Big man.
You're a hit over the head, Macho Man.
Oh, no, man. I'm all right.
It's never been better yet. Don't you worry about the hit over the head, man. I'm just worried about where we're going from here. Is it this stratosphere, man? Is it the ionosphere with the madness and the mania as one guiding force? We could go ahead and take the whole
I cannot believe it. Here on Saturday night's main event, the Mega Powers, the Madness, Macho Man Randy Savage, and the heavyweight champion and Hulkamania. Wow.